guys, so number one for this paper 2 is a pretty intense trigonometry problem. And so before we even get into parts A, B, C, whatever, okay, we first need to really understand the tools we have in the world of trigonometry. And there's 3 main tools that you will embark upon. So for trigonometry, I really need all of us, because once we understand this, the rest of the exercise will flow very smoothly. We all need to understand the main 3 tools for trigonometry. The first one, which is the one that I suggest the most, is Sine Rule. Okay, I immediately need you to associate or write down in your notebook or paper that Sine Rule works in pairs. Then you have Cosine Rule. And Cosine Rule, I need you to write down somewhere in your pen or pencil or paper or whatever that you use Cosine Rule if Sine Rule doesn't work. I'm not even kidding, okay? And last but not least, the third one that it's common to forget, honestly, is that you do have a way to calculate area of triangles using trigonometry. And this you will use if you don't have height. Now, why do you use the trigonometry formula for area of triangles if you don't have height? Because what we're used to doing, okay, if we look at our formula booklet, is if we look for area of a triangle, the classic is the one up here. Base times height divided by 2. Base times height divided by 2. You've probably done this like 100 times. Okay? Well, the other formula for area of a triangle, bada bim, bada boom, here it is. So look at that. You can't find the area of a triangle without the height. Over here, you need the base and the height. Down here, what you actually need are 2 sides and 1 angle. Now, you might be looking at this and asking yourself, how the heck do you know these are 2 sides and 1 angle? And that is why I need to explain the formulas just a little bit. See? So the first thing I also need us to really understand and hone that and like really hone into, focus into, is the following diagram, okay? In your triangle, okay? Let's say we call this side A. So if this side is little a, then its respective angle is going to be big A. And I can also go backwards. I mean, if this angle here is big B, then the little side associated to it is going to be little b. So, look at that. Lo and behold, you can also figure out that if this is big C, then this side over there has to be little c. Okay, so that's the first observation I will like sort of point out, is that small letters in the context of these formulas are going to be sides, while big letters are going to be angles. So big letters for angles, small letters for sides. And so technically, if you look over here, that's why this guy online was telling me that sine rule works in pairs. Because if you look at the sine rule that's up here, okay, if you look at the sine rule that's up here, we'll take a good look. First of all, you have 2 equal signs, okay? So technically, you can use it like this, like little a divided by sine of big A equals little c divided by sine big C. Or you can use it like this, comparing only A with B. Or you can use it like this. Okay, so that's the first observation I'm going to talk about. It works in pairs. You use whichever pairs you want. So for example, coming back over here, my sine rule, we said, right, is that you compare technically 2 sides with 2 angles. See? Now the more intuitive version of this, right, if I were to get rid of the letters and put maybe words into it, is that technically all you need is side 1 divided by sine of angle 1, so its corresponding angle, the side with the corresponding angle, equaling some other side divided by sine of the angle in respects to that other side. See? So technically from here, if you have 3 out of 4, let's say you have side 1 and angle 1, and you have side 2, this is good enough for you to find angle 2. Okay, so as long as you have 3 out of 4, you can find the last one. That is why I tell you to think in pairs. The moment that you have a single pair, a single side with a single angle, then you can probably find some other missing side that you don't have the angle of, and using the sine rule, you'll figure it out. So the moment you have a single pair, sine rule is probably something you can use. Okay, that's what I'm trying to tell you. That is the blah blah I will give you for sine rule. Got it? For cosine rule, we're only going to use it if sine rule doesn't work. See? And I know this equation might look kind of nasty, but the only observations that you really have to do is that you have 2 formulas for cosine rule. See? You do have a semicolon here, so that means that you can pick between either. And really, they ask for the same thing. Okay? The only observation that I'm going to draw from here is that one of them has a side alone, while the other one has an angle alone. Okay? The other thing I'm going to mention is that it does matter which angle you're leaving alone or which side you're leaving alone. Because notice, in this context, whatever you call A or whatever you call B is simply going to add each other. It's simply going to multiply each other. And that is the scenario in both cases. So if you switch up A with B or B with A, nothing's going to change in your procedure. A plus B is the same as B plus A. A times B is the same as B times A. So switching up A and B doesn't matter, but switching up C here really does. Because you only have cosine C, so you really have to be careful. The side that you're trying to find, whatever angle you put inside has to be its corresponding one, okay? Or also over here you have minus C, okay? If you confuse sorry. If you confuse A with B, it doesn't matter here. But if you confuse C with B, well, one of them now has a negative, the other one has a positive. That's going to change a lot to your approach. See? So that is the small observation I would do here. Notice which one you're having alone, okay? And work from there. See? Anyways, cosine rule, you're only going to use it if sine rule doesn't work. See? So I'm not going to get too into it. Let's just see it in action later. And last but not least, the area of a triangle for me is very visually appealing. See? So again, following the same idea that instead of talking about A, B, C, and all that stuff, I'm going to call them side 1, angle 1, side 2, angle 2. In this context, if I were to put this in a little more friendly way, I would say that the area of a triangle, you can calculate it as 1/2 times side 1 times side 2 times sine of angle 3. And so notice, this, for me, I can explain it more in a visual aspect. See? So whichever sides you end up picking, the angle that you put into this formula has to have nothing to do with those sides. Notice you have side 1 times side 2 times sine angle 3. So this angle has to not be associated to either of the sides. From a more visual aspect, you can find the area of a triangle. For example, I'm going to draw 3 of the same triangle. See? And I'm going to give you the 3 scenarios where you can use this formula for area of a triangle. See? So the first scenario, following the colors as well, you can have side 1, you can have side 2, and the angle that is in between. And notice this angle that is in between is associated to this side here, which clearly has nothing to do with side 1 and side 2. So this is a scenario where you can use, or you can find, the area of a triangle. Got it? The other scenario following that idea would be maybe this side and this side. And so the remaining side is going to be this guy here. So the corresponding angle, of course, has to be this guy there. Oh, look at that. So basically, at least for me, from a visual aspect, it's a lot more friendly. Basically, if you have 2 sides and the angle in between them, you can find the area of the triangle. Yes, it is that simple. Yes, we will have to use it. See? So these are the 3 scenarios for area of triangle. You now know all the tools you have to know. Write this down somewhere. Get familiar with them, because once you understand it, this exercise over here will turn out to be very easy. Dale? So let's jump into the action now that we understand these formulas a little bit better. From here we have that the diagram shows points in a park viewed from above at a specific moment in time. We have that the distance between 2 trees at points A and B, so this is tree 1, this is tree 2, is 6.36 meters. One small observation: anytime they give something of information of your diagram, make sure that it's there. So this 6.36 is right here, okay? So all good in that sense. Make sure your diagram has the information that they give you. If not, put it in yourself. Odette is playing football in the park and is standing at point O. So at point O, we have our good old friend Odette. Such that AOB is 10 degrees, which is already written into my diagram, so I'm going to check it. Then they tell us that OA is 25.9, all right? And that OAB is obtuse. So this distance is already written here, so that's cool. And when they tell us that OAB is obtuse, let's remember, you can have acute angles, you can have right angle angles, sorry. So this is in the context for angles, okay? You can have acute angles, you can have right angles, or you can have obtuse angles. All you really have to know is that for acute, it's any angle that is less than 90. Right angles are angles that are equal to 90. And obtuse angles are angles that are greater than 90. And so from here, it's pretty clear that it's going to be an angle that is bigger than 90, but nonetheless, it might be relevant later on. So OAB, which is basically telling you the angle formed between O and B. So between O and B, clearly you have angle OAB at A, basically. You know that that angle is obtuse. See? So for part A, we need to calculate the size of ABO. ABO. So if we need to find this angle here, well, what did this guy online tell you? First of all, you should probably not trust guys online, but at least in terms of math, you can trust me, okay? That being said, for calculating the size of ABO, this guy online told you initially you have 3 main tools, and you're going to start off with sine rule. See? If sine rule doesn't work, then go to cosine rule. ¿Vale? So your procedure will always be try sine rule. If it doesn't work, go to cosine rule. I know there are other ways to solve this faster. I know you've probably heard of SOHCAHTOA, but to be honest, I'd rather give you tools that always work. So an approach that will always work is try sine rule. If it doesn't work, go to cosine rule. Okay? So I know there are quicker ways, but my procedure that I'm going to show you today is like the conservative way, what's always going to work. You might take a little bit to get there, but you will get the answer. See? So this guy online told you first try sine rule. He also told you that for sine rule, it works in pairs. So do you have a pair here? We'll take a closer look. Technically, this angle here is associated to that side there. So check, I have at least one pair. And the angle that you're trying to find over here, which we will call X, has associated to, boom, that side here. And you actually have that side. So look at that. You have side 1 and angle 1 right here. Side 1 is 6.36, angle 1 is 10. And then you have the side 2 right here of 25.9, and you don't have the angle of that 25.9. So sine rule here actually works perfectly. So let's first write down the equation. So A divided by sine of A equals B divided by sine big B, right? So the other thing, I'm gonna just put a disclaimer here in case you're not so familiar with it. Remember, small letter is the side, while big letter is the angle. If you have trouble remembering that, take a good look at the formula. Sine big A is for angle, see? And so whenever you have sine, cosine, and tangent as a function, you always put an angle inside. You never put a distance. See? So that's another way you can remember it. What's inside the sine, cosine, and tan? Angles. And so if a big letter is inside of sine, then big letter must be angle. All right. In this context, I know it says A and B and stuff like that, but you define A, you define B, you define what is side 1, angle 1, you define what is side 2, angle 2. Okay? I know the letters can be confusing, but the more intuitive part is what should remain for you. Be consistent. First angle with first side with second angle. Okay? It doesn't matter if this point is called A or this point is called B. You define it however you want. Dale? So what I'm going to define it as is I'm going to say that these guys in green will be my first pair. See? So if these guys in green are my first pair, that means I have 6.36 divided by sine of 10 degrees equaling, and now it's the part in black, certo? So my my side for that angle X is going to be 25.9 divided by sine of X. And from here, you just need to get X alone. The procedure will always be the same. You will be technically, you will cross multiply here. So from here, you do this times this equaling this times this in an attempt to get X alone. So if you go ahead and do that, which helps you get rid of the fractions, by the way, you end up with sine X times 6.36 equals 25.9 divided by sine of 10. From here, in order to keep getting X alone, clearly you have to divide by 6.36 so that, you get X further alone, right? So that goes away with this. So you end up with sine of X equals 25.9 divided by sine 10 times 6.36. And from here, the interesting thing you have to do is that X, in order to keep getting it alone, it's within a parentheses. And so if it's within a parentheses, you need to get rid of whatever is right outside. And what's right outside, sort of, right? I know that technically no, but what's right outside is the sine function. So how do you get rid of the sine function? Well, just a little bit of context. If you were solving an entirely different problem, like 2y equals 4, and I tell you to solve this, well, what do? Of course, you're going to tell me you divide by 2. Okay, but why do you divide by 2? You divide by 2 because this 2 to the y is multiplying. And what is the inverse function of multiplication? Division. So that's why you divided both sides by 2. So whatever is affecting your variable, you do the inverse in order to get it alone. If it's being multiplied, you will divide. If it's being, added to, you will subtract. And if you have a sine, you have to do inverse sine. Look at that. So if you do inverse sine from here, well, you got to do it to both sides, right? I mean, it's the same as like simply dividing or multiplying by 2, just that in this case, it's going to be sine inverse. So if you do it to both sides, the magic that happens is that this goes away with this, and you end up with only X. So X will equal sine inverse of that whole thing, okay? Before I plug it into my calculator, it is very important that in mode, you have it in degrees, okay? The common is to have it in radian, as I just did just now. Make sure that in mode, you change it to degrees, because this does change how your sine behaves. So sine 45 in degrees is this, while sine 45 in radians is actually going to be this, okay? Small detail, I'm not going to get into why, just for us at AISL, focus on leaving it on degrees every single time. Got it? So now that we have it in degrees, we can go ahead and plug in sine inverse of that whole thing. Sine inverse is on top of sine, okay? So you do second sine to hit sine inverse. We're putting a fraction here, so I'm going to put alpha y equals and press the first one just to plug in a fraction more easily. So I'm going to go ahead and solve it from here. 25.9 divided by sine of 10 times 6.36. Close parentheses, keep it nice and clean. Error in domain. All right, I probably wrote something wrong somewhere here. So sine inverse of 25.9 divided by this, da da da. Why would sine 10 be wrong? Da, da, da. Let me check my work. I'll leave it in the video because this is relevant for the approach. Boom, boom. Boom, boom. Okay. Cross multiply. Okay, yeah. So, I'm leaving it in the video because everyone makes mistakes and this could happen to you as well. Whenever you have a domain error, the first thing you should check is, okay, is something in did I plug in something wrong? Now I double checked and nothing was plugged in wrong, but I did have a pretty massive mistake, which is right when it cross multiplied. See, right when it cross multiplied right here, what should have happened, right? I did have sine x times 6.36, so that's good right there, but I should have also done 25.9 times that sine 10. And I divided it immediately, and I don't know why. All right, so that's my bad. Technically, from here, I should have that 25.9 times the sine 10 times the other guy. See? So this is divided by 1. Yeah, there it is, right? And so from here, this sine 10 is actually on top. So 6.36 times sine 10. All right, usually I would edit it out, like do the problem again and stuff like that, but I'd rather keep it real, you know? This is math. Everyone makes mistakes. Even this guy on YouTube, even this random guy on the internet, everyone does mistakes, okay? The important thing in life in general is what do you do after those mistakes, see? So check your work, learn how to improve. Learning how to think is the most important thing, see? Not knowing what to think, instead learning how to think. And a big part of that is correcting yourself in the appropriate way. So I checked my work. That was the mistake that I had. I go back over here. I'm going to clear probably everything. There we go. So now it should work. See, so 25.9 times sine of 10 divided by this guy here, 6.36. There we go, there's my answer. It's basically 45 degrees. Let me show you the mark scheme so that you guys actually trust me for what is the remainder of the video. There it is, yeah, 45 degrees. Notice how you get literally a method point just for trying the sine rule, see? So, in this context for part A, for angle ABO, so part A, we will have 45 degrees. See, you could just leave it as 45 to be honest, okay? So that is for part A. Later on for part B, it asks us to calculate the area of triangle AOB. And so the triangle that you have right now, if I were to redraw it, see, so this is for part B. Technically, the triangle that you have right now is that over here you have 10 degrees. Yeah. Over here, you just found that this is 45 degrees. And you know that this side here is 25.9. And that this side over here is 6.36. Yeah. Now, for area of a triangle. For area of a triangle, I mentioned way earlier that you will use the formula for calculating the area of a triangle if you don't have the height. And in this context, the height of this triangle is actually pretty hard to come across. See, you would have to like do even more trigonometry to try to find the height of this triangle. See, so that's a little bit harder. And so because we don't have the height, we're going to be using the trig formula for area of triangle. Now, the trig formula for area of triangle, as I mentioned earlier, is that you need two sides and the angle that's in between. You need two sides and the angle that's in between. So in this context, well, the two sides that you have are right here, right? So following the color coding, you have these two sides right there, and you need the angle that is in between. Technically, I could try to find the other side down there and use one of the other angles, but I think it makes a lot more sense if I work upon the sides I already have and try to find this angle here. Now for this angle here, it's fairly straightforward. The degrees inside of a the degrees inside of a triangle add up to 180. So 180 degrees, adding up all the different angles, has to equal, well, my missing one, which we will put it as just green. ¿Cierto? So the missing one in green, yeah? The missing one in green plus 45 degrees plus 10 degrees. And so 180 degrees has to equal what we have in green plus 55 degrees. Okay, so in this context, you're going to end up with the angle in green being 180 minus 55, 125. So this angle in green is 125. That means I can now officially use the formula for area of a triangle, which is right here. So area of triangle, whoops, is 1/2 times AB times sine C, which, as we mentioned earlier, is really just two sides and the angle in the middle. So side number 1, I will call it the 25.9. Side number 2, I will call it as a 6.36. And the angle in between is obviously going to be sine of 125. So all of this into your calculator. Trust the process always. If there's one thing that's cool about the AB is that the process and the methodology is very repetitive. So once you learn it a couple times, trust the process, trust yourself, trust the hours of study you've put into this. Put it all into your calculator, take it a minute, and there you go. So the area of this triangle has to be 67.467. 67.467. We are talking about meters. This is all in meters, so this is going to be meters squared. Okay. If you wanted to do significant figures, you count 1, 2, 3, round it up or keep it the same. You round it up. So in significant figures, you can leave it as 67.5 meters squared. So that is for part B. We check our answer just to keep things clean, and there it is. Okay. So notice once again, all you really had to do was notice that you need to use the area of a triangle formula. Okay. So once you realize that, you're good to go. This angle right here, well, because I use sig figs or whatever, you can leave it as 125. It also works. Okay. No worries there. That was just the decimals thing. See? In other words, in case anyone is freaking out in respect to the answer key, if you did it using this number, you would get that number. ¿Vale? And you would get this. But if you round it just a little bit, which is completely legal, this would end up as 125. Here you would plug in 125. You end up with 67.5, which is exactly what happened over here using significant figures. Okay? So no worries there. Everything is good so far. Then it gets kind of wild, right? Because they tell us that Odette's friend Khemil is standing at point K such that he is 12 meters from A, and also for some reason we know that angle KAB, which is this angle here effectively, is 45 degrees. So everything in my diagram is, still there, nothing new or nothing hidden to discover. And so for part C, we need to calculate Khemil's distance from B. So all you're really working with is this triangle here, okay? Yes, they're putting a bigger diagram because they're adding on to the context of the previous triangle, right? Because the previous triangle is right here. So they're adding on to that previous sort of context. But really, all you need for part C is this triangle here. So yes, you actually don't need parts A or B for what happens now. So you have this triangle here. You have one of the sides. You have the other side. And you have the angle in between them. And so for calculating Khemil's distance from B, you need this last sort of side. So what do you have? Okay. Well, this guy online told you, always try to use the sine rule, and if you can't, go to cosine rule. So from here, do you have a set of pairs? Well, this side is associated with this angle, so there's no pair there. This side is associated to that angle, and so there is no pair there. And this side is associated to that angle, so there isn't a complete pair there either. Now this guy online told you, yo, if sine rule doesn't work, go to cosine rule. See? So I go to cosine rule. For part C, we need to calculate a distance, right? So if we're calculating a distance in cosine rule, as I mentioned earlier, one of these, the one on the left, if you take a closer look, has a side that is alone, while the one on the right has an angle that is alone, okay? And when I say alone, it's like c squared, little c squared equals, right? So it's isolated by the equals. That is what I mean by it is alone, okay? here you have as cosine C equals, and so the angle is alone in that sense. So let's go ahead and write down the formula over here. The formula is little c squared equals a squared plus b squared minus, I think, yes, minus 2ab cosine C. And so all we really have to do, quick recap from before, is that whatever side is alone, you need to have its corresponding angle. So wow, look at that, how convenient. And yes, it is that convenient in the IB. When the sine rule doesn't work, you usually end up using the cosine rule, and you have just what you need for the cosine rule. ¿Vale? So the methodology that you apply is absolutely essential. Trust me on this. Sine rule didn't work, you go to cosine rule, they're asking for a distance, so use the cosine rule on the left side, and you go ahead and just fill it in. You just fill it in and forget about it, see? So the big idea here is that this side here, C, which we're gonna call this side here in red, ¿cierto? Has associated to this angle right there that is also in red, right? So as long as you're consistent with that and have the other two sides, you're good to go. Which you do. We're gonna call A this light green side over there, and we're gonna call B this light blue side over here. So if you go ahead and plug in from here, clearly you end up with c squared equals 6.36 squared plus 12 squared minus 2 times 6.36 times 12 times cosine of the angle in red. See, so 45. ¿Vale? From here, just to keep things clean, I guess, since we are talking about the distance of Khemil from B, so it's from K to B, this is the distance KB. Yeah? And so just to keep things clean, I'm going to put KB over here so that we all understand what's happening here. See? I'm going to put a little bit of a line on top to show that we're talking about a line, we're talking about a distance. Okay? Yeah. So KB squared, in order to get rid of the squared, you have to do square root to both sides. Because if you do square root to both sides, this goes away with this. And that means that you have square root of this whole thing right here. See? So in other words, for getting KB, I think I might have gone a little bit faster. So let me go again. See? So in this context, we're talking about the side KB. That it? Now, following the formula, you have c squared. And so in order to get rid of the squared, you just gotta do square root. So if I square root everything onto both sides, this goes away with this, and you end up with KB alone. So KB equals the square root of the entire thing on the right side. So KB has to equal the square root of the entire thing on the right side, which will be 6.36 squared. So that's this guy here, ¿cierto? Plus 12 squared. Whoops. Minus 2 times 6.36 times 12 times cosine of 45. Make sure it's all within the square root. You press enter. There it is. So Khemil's distance from B, in other words, the distance from K to B, has to equal, or it equals, better said, 8.747. All right, and if you were thinking in terms of significant figures, you count 1, 2, 3, round it up or keep it the same, you round it up. So in significant figures, if you'd like, you can leave it as 8.75. Right? We are talking about 3 points here, so keep in mind the units. It's all in meters. So meters. Just so you believe me, here it is, 8.75 meters. So again, you just have to realize you have to use the cosine rule. Now, a lot of people ask me, how do you realize you have to use the cosine rule? And it's not that I realize I have to use the cosine rule because no one knows the formula by heart, but you do have a procedure associated. So try the sine rule. If it doesn't work, you will use the cosine rule. Like I can bet my life on it, okay? Especially for AISL, that is a procedure that you gotta follow, okay? Keep it in mind, trust me on it, at least for this one, see? Yeah. So that is for part C. then it gets kind of wild with the last two parts. See, for part D and E. They tell us that XY is a semicircular path in the park with center A, such that KAY is 45 degrees, which is written right here. Khemil is standing on the path, right? And so Khemil, which is at K, is on this path right there. And so the path, or in other words, this half circle, point K is on it, okay? And they tell us that Odette's football, this is important for later on, Odette's football is at point X. So right here at point X, we will have the football, okay? Then they tell us that length KX is 22.2. So this right here, which I'm putting in green, is 22.2. Okay. KOX, so another thing that is actually not on my diagram. So KOX, so angle O with the sides K and X. So KOX, if you were to put some lines over there, this angle is 53.8, and what I will be putting in pink, angle OKX, so OKX, so OKX, so this angle here has to be 51.1. Alright, so now I made sure that everything was in my diagram. It usually is, but notice for part D it wasn't. So always check the information that they give you. Make sure it's in your diagram so that you can visualize it all a little bit better. So for part D, we need to find whether Odette or Khemil is closer to the football. So let's recall. From part B, we know that Khemil, or for part C better, we know that Khemil is standing at point K. So at point K, we have our good old friend Khemil. While from way earlier, they told us that Odette is playing football, blah, 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 and is standing at point O. So Odette right here, or better said, Odette is right here, okay? So of these two people, who is closer to the football? The other way to understand it is point O or is point K closer to X? Okay, so really what I'm dealing with is this triangle that just got created between red, pink, and green. So let's redraw it so that it's a little bit easier to handle. So right now, you know that this is 53.8 as an angle, ¿cierto? You know that this is 51.1 as an angle. You know that this side is 22.2. You know that here you have Khemil, here you have Odette, and here is X for football. X for football, I don't know why, but okay. So this is what you know about your triangle, right? So all you really have to do now is, you know the distance Khemil has to the football, it's 22.2. From K to X, it's 22.2. Now all you have to do is find the distance from O to X. Compare both and see what happens. So, trigonometry. Again, same procedure. First try to use sine rule. If not, go to cosine rule. So, sine rule works in pairs. Do you have a pair here? This angle goes with that side. You have a pair. And this angle goes to that side, which is actually the side that you're trying to find. You're trying to find OX. So wow, look at that, sine rule works. More than that, the procedure works. First do sine rule, then do cosine rule. Trust me, it'll be okay. Dale? So again, the formula is A divided by sine big A equals B divided by sine big B. So in this context, the first pair, I will use the one in pink. So the first pair is 22.2 divided by sine of 53.8, equaling the distance you're trying to find, which is OX, right? So the distance OX divided by sine of 51.1. And so now we make sure to not do the same mistake from before. If you want to get OX alone from here, because it's at the top, you can actually just multiply by sine 51.1 to both sides. Why would you do this in the first place? You do this because then this goes away with this, and you end up with OX as a distance being alone. Okay, so that is what you can plug into your calculator. That helps you find the distance of OX, which will be well, obviously I have the fraction, right? So you have the fraction 22.2 times sine 51.1 up top, which is what's in red, divided by sine 53.8. Here I didn't really put the point very specifically. I have a 53.8. ¿Vale? Yeah, go ahead and press enter. There it is. Distance OX is 21.499. Okay? So, just so that we're on the same page, there is the 21.499. Okay? And as I was mentioning earlier, now that you filled in this triangle over here, 21.499, now you have to compare who is closer. And basically, which number is bigger, the 22.2 or the 21.4099? Clearly, the bigger number is 22. All right? Don't fall into the trap of the 499, which sounds kind of big, right? Like 4,099. It's after the decimal. See? It's after the decimal. So, clearly, 22.2 is bigger than 21. 22 is bigger than 21. So if 22 is bigger than that 21, right, then that means that kx, distance kx, is bigger than distance ox. And so if kx is bigger than distance ox, then Khemil is farther. And that being said, Odette is closer. It's very important that you do this mini sort of conclusion near the end. See, never forget what they're asking for. They're asking for you to find who is closer to the football. So it's not enough to do the trigonometry and this fancy math. You also have to conclude. That's also why it's worth 4 points. If you look at the mark scheme, you literally have a whole point that is you figuring out who is further from the ball. See? So careful with that, especially when it's worth a lot of points. There's probably 1 or 2 extra things you got to do. ¿Vale? So that is for part D. And last but not least, part E is a little bit different. So we have that Khemil runs along the semicircular path to pick up the football and to calculate the distance that Khemil runs. And so this is a little bit harder, right? So let me erase the diagram for a second, because now we're not really talking about trigonometry anymore. Now we're talking about a circle. So oof, now it got a little bit harder. See? So let me erase this diagram. Let me clarify exactly what they're asking for and exactly the tools that we can use. So first of all, it's not trigonometry anymore, because trigonometry is for triangles. It's for triangles. This isn't a triangle anymore. See? So we have that our good old friend Khemil is running along the path in order to reach the football. And we need to see how much the distance in pink is. Now, what do you know? Well, you know a couple of things. Dale? You know that when you're talking about circles, you have 2 main tools. Okay? Your 2 main tools for circles are in the formula booklet, which is actually right below to what we were looking at. On the one hand, you have length of an arc and area of a sector. So when you have a circle, okay, this can often get like split up into pizza pies, pizza pieces, whatever you want. See? So if you cut it up like this, the language that we're using here, okay, is that this in red, this in red is your sector. So for area of sector, right? While this in green will be your arc. Ah, okay. And so in this context, you also have a circle. I mean, you actually have, because they talk about a semicircular path, so we are talking about circles. So the 2 main formulas are for length of an arc and area of a sector. So this is for circles, okay? Both of these are for circles. Now, in this context, because we're talking about the distance that Odette that Khemil is going to run, we will probably end up using the one for length of an arc. Area of sector, probably not, but let's keep it in mind. It's there, it does exist. Yeah. Now for using either of these, all you really need is the angle for your arc, right? So if this arc in green, that means you need this angle there. And same for the sector. I mean, if you're going for this sector and putting in red, then you need this angle here. You need the same angle, okay? It's whatever. Here's the thing. For the length of an arc, you need the sides that compose that arc. And for area of sector, you need the sides that compose that sector. I mean, the angle in between those lines, whatever, etc. See? Fair, sir, makes sense. Yeah. Enough talking. Let's get into it. So, from here, do you have the length of this sector? See? On the one hand, you know that it's a semicircular path. And so this 12 right here, well, what is it? Well, if you were to complete the circle, right, this 12 also shows up here. It also shows up there. It also shows up here. And so this 12, you guys, it does take a little bit of creativity to really see the circle, really see the semicircular circle. But from here, the two main hints are the following. You know it's a semicircular path, okay? And they also tell you, okay, that Khemil is standing on the path, right? So this K is on the path. And so if this is 12, right, and the semicircular path has a center A, then from A to K, you're going from the center of the circle to the edge of the circle. Center of circle, edge of circle, 12 is your radius. This 12 is a radius. So, that's the first big observation you have to go for. The second big observation you have to go for is that the length that is in pink, well, what is the angle associated to? It's the two sides associated to it earlier, right? So this guy in green, I need these two sides in order to understand which angle I need to get, right? And so this arc in pink, I need to understand that we're talking about from here to here. And so we're talking about from here to here, that I need this angle there, okay? That's the big next sort of question you have to ask yourself. See, which angle do I need? Because your formula does depend on an angle. That is, so the formula for length of arc, you have L equals your angle, theta, ¿cierto? Divided by 360 times 2 pi r. So all you need is to figure out your angle and figure out your radius. I already figured out my radius, and for figuring out the angle, because I'm going for the part of the arc that's in pink, then I need to understand that, okay, so this arc finishes here, and it also finishes here. So boom, boom, the angle you need is this guy right there, okay? Yeah, how the heck do you find that guy right there? Well, I can immediately tell you, with a little bit of quick maths and a little bit of magic, that it's 135 degrees. Now, how the heck did this guy online just do that? He just did that because you need to know that a straight line has 180 degrees. That's also why if you have a straight line and you put a vertical line through it, you have 290 degrees right here. Because 90 plus 90 gives you that 180. And the other thing that can help you understand is that if you were to do a circle from here, well, you have another 180. And 180 plus 180 gives you that 360. Bada bing, bada boom. So this is kind of like common math knowledge that you do need to know. Okay, a straight line adds up to 180. And so if this is 45, that means I can do 180 minus 45 in order to get this guy right here. And so 180 minus 45, just so that we all agree, although I'm pretty sure about my math, but let's be honest, anyone in a test puts everything into your calculator, even if it's 2 plus 2. So there it is, 135 degrees. Dale? So here's the 135 I need for my theta, okay, which again, I did explain it intuitively, but the formula here literally says that theta is the angle measured in degrees, right? That makes up your arc, while r is the radius. So I already found theta, I already found the radius. It's all in degrees. Everyone's happy. All I have to do is plug into this formula right here, which ends up as length equals 135 divided by 360 times 2 times pi times r, which you said was 12. So all of that into my calculator. I like to use the fraction thing because it's easier to plug in. To each their own, whatever floats their boat. 135 divided by 360, that's this part here, times 2 times pi, which is going to be right under clear. So you press second, then this little arrow thing, hit the pi button, times 12. All of that, you press enter, bada bim, bada boom. The distance that Khemil runs has to be, for part E, following this formula right there, 28.27433. If you like significant figures, you can count 1, 2, 3. Do you round it up or keep it the same? You round it up. Make sure you put your units. We are talking about meters all along this exercise. I show you the answer so that you believe me. There it is. All right. You can leave your answer in terms of pi. I don't like to. Okay. To each their own. That is. So you can leave it in significant figures, the entire number, or in terms of pi right there. See, with the 9 pi. When I say in terms of pi, basically what they're doing, just so that you know, is that they don't multiply by pi. See, they leave pi right outside. And so that is how they reach 9 pi. Dale? All right, you guys. For me at least, and this is a closing remark. For me at least, there's two main things I can observe here, right? This is a trig problem. And trig problems are not that hard once you understand the formulas. See? So understand these three formulas, understand that you're going to be using them a lot, and understand that A, B, and C doesn't matter. What matters is how you define them. Okay? Be consistent. Little a has to go with big A. Little b has to go with big B. It doesn't matter that your exercise had the letters A, B, and C, and O, and whatever in between them. What matters is how you define the pairs, how you define what goes with what. That it? So don't get confused by that. Do the sine rule first, then do the cosine rule, and more often than not, you do end up calculating the area of triangles when you don't have the height using the trig formula, which is not that hard. For me, from a visual aspect, you can notice more quickly when you have to use it. All you need is the two angles and, all you need is two sides and the angle that is in between, okay? And the last part, which was like a circle thing, right? Lo and behold, it's paper 2. Paper 2, what it does is that it mixes different units together, see? I know that problem 1 technically is like geometry / trigonometry, okay? But for us, it's like, it's mixing trigonometry with length of arc and sector and stuff like that. See? So the catch about paper 2 is that it has problems with like that mixes stuff. See? Even if we look just quickly at, for example, I don't know, maybe number 4, right? Here we're talking about probability, then we talk about variance, then down here we talk about a p-value. So it's not just probability, it's also like doing like t-tests and stuff like that. So the thing about paper 2 is that it sort of has like 2 exercises in one. See? Why is it worth mentioning it out loud? Because even in this exercise, I bet that you can skip from A to D and you can do only E to H because it's literally 2 exercises in one. Okay? That's the cool thing about paper 2. You can claw for points almost anywhere. Even in this exercise just now, you could pretty much do almost all the parts by itself. See? I think A and B were very associated, but like C and D, you can do them by yourself. E as well. Like, I mean, you know what I mean? Like, paper 2, the catch it has is that it mixes a lot of exercises in one, and that can work in your favor. ¿Vale? So keep it in mind. That is number 1 for paper 2. A very thorough explanation, but I think it's a very worthwhile one. See? A lot of the context was understanding the formulas. Once you do that, you will be just fine. Ladies and gentlemen, I hope it helped. That is for number 1.